Okay, folks, maybe just get started. Welcome to your first afternoon session. My name is Alex Lin. I'm the Senior Technical Product Manager working in Penguin Computing. And again, it's just the first session of afternoon. So hopefully you enjoy your lunch. I like it better than last year's. So even though it's not hard, but still works. Anyway, cool. For my session today, I'm gonna talk about the new recommended profile. The agenda consists with, of course, introduction of who we are, Penguin Computing, what do we do, and how we think OCP is important to us and also to of the community. So we'll start with go through some highlight about the rack profiles and why we think the one we are proposing is important. And welcome to all the feedbacks. So a little fact about Penguin Computing. We are based in Fremont, California. Has been 20 years. And we are the global solution provider for HPC, hardware, software, and also services. So other than the hardware platform, we also provide the cloud service. It's called Shared WAF Cluster software. So AKA is a Penguin Computing on Demand, or POD. A little bit software flavor into our portfolio so far. For the OCP racks, to the date, we have already shipped more than 300 racks so far. And our CTO, Phil Proconi, he's also the OCP HPC representative and the Tula committee. So, a quick review about the Open Rack history. So, Open Rack, as you guys knew, is innovative standard since 2012. So the idea is to enlarge the rack unit and the width from the traditional EIA 19-inch rack. And also it can provide a better cold I/O installation and service environment by reversing the airflow. So since 2012, the major update is the version 2.0. So in OCP standard 2.0, it including two different depths, 800 millimeters from V1 and 660. The shorter depth is new, and also not only the 12-volt DC bus bar, it also started including the 48-volt DC. Traditionally used mostly from telco. So since the launch of the 2.0, now we have multiple options. Try to think about that. You have two options for the rack depths, two bus bar voltage, 12 volt versus 48 volt. And I have mentioned about the bus bar numbers. So from the version 1 is 3 bus bar, and the version 2 is 1. Then the fourth parameter is rack units. For example, you might have a 40 OU rack or 44 OU rack. So we have many options. If we lay down some major profile in this chart, you can see from the 12-volt DC space from the V1, Facebook and the Penguin, we use a deep depths. And since the version 2, Facebook also use the 1 DC bus bar options. And the other big cloud service provider, Google, they also use they start to use the OCP, but the 48-volt version, but with the short depths. So if we just took the 3 parameters from previous slide, we have 8 combinations. What if we have different units? How many? Yes, 2 by 4, so it's 16. So there are a lot. Then just a quick review for those major profiles will adapt. The 12-volt DC plus 1 DC bus bar is compliant with the Open Rack standard V2 and with the deep depths. The 12-volt DC with 3 DC bus bar, that's a V1, which Penguin we are still using. It provides a high density, high power capacity, and a robustness. The 40-volt DC and 1 DC bus bar is new. The advantage to have a 48-volt DC is to provide the better power usage efficiency from the electronics point of view. And we are going to submit our profile for technical review by Q2 this year. Anyway, I only highlight the 3 key profiles. However, back to the previous chart, they were 8 or even more. So, which leads to the next question. The original purpose to have an OCP is to trying to make things easier, simpler. If we have too many questions, it will make the deduction of the build cost difficult, because we need seriously we should have a more common part and a more common design than multiple options. That's engineer's idea. So we are trying to propose something which can provide the optimized infrastructure design, and which can provide the better efficiency, flexibility, and the scalability as the original OCP stand X4. So, and also try to reduce the waste. Okay. So Penguin's recommendation for the next gen OCP rack is based on the current 48-volt DC rack. However, we still prefer to choose 3 DC bus bar over 1 DC bus bar. There are a couple of reasons. First of all, it can maximize the density. In our current solution offering, like the Tundra 1U server node, we can provide 3 nodes in 1U high. So with the 3 bus bar, we can easily support over 100 nodes per rack. The second reason is to provide a more a better cost effective from design's point of view. It will be more easier and also cheaper to deliver more than 33 kilowatts with the 3 bus bar instead of 1, because you don't need to make make your material and of the DC bus bar not much, and you can distribute that to the 3 bus bars from mechanical and the materials engineering's point of view. Also, it is more easy to distribute powers to the whole rack by using 3 bus bar as well. For the positioning of the power shelf, we also propose to put the light in the middle, not on the top or bottom, to distribute the power more evenly. The third reason is the flexibility. By using the 3 bus bar, it is actually also easier to convert the existing IT devices. So, for example, if you have an AC power 19-inch networking server, usually the AC power supply is on either side, maybe on the left or right or both. So if you have the DC power module, you can easily to swap it in without redesign the whole chassis. In that case, we can use either the left or right DC bus bar But if you only have the V2 with one bus bar in the middle, you need to design the whole thing. That might work for some special case, or if you have a big enough project size to kick off that design. However, our majority customer, they are enterprise, so we try to utilize the same general design as much as possible. So, any question? Yes. Sorry.
Could you elaborate a little bit more on the placement of the power shelf? Why is that more better distribution?
It is from electricity distribution's point of view. So you have a whole rack to distribute the power to make sure the power delivery to the far end still enough. Putting the power shelf near to the middle is the most logical way. Otherwise, the design for the bus bar need to be you might need more copper, or the transmission adaptive rate needs to be better. So we have already checked into couple bus bar design vendors. They all reflect the same thing. So typically in our rack configuration, we will, if it's only a single shelf, we'll put a light in the middle. If it's a multiple shelf, then we'll distribute more evenly, like close to the slot 11 and the 30. Okay.
Yeah, I'd just like to see a break. I'm not asking for that now, but I'm asking for it later. A breakdown of the cost at the IT load, it costs all the way through, because you've increased the number of connections required, and so that connection is fairly expensive, and so I'd like to see that breakdown.
Okay, yeah. Wow, this goes fast. Yeah, so anyway, for the quick conclusion part, we recommend to still embrace the 3 bus bar design when we move to the 48-volt DC. Although we think that that's the most convenient, flexible, and higher capacity design. And in our proposal, we will continue to use the deeper depths, the 800 millimeter one. So for the existing IT gear and the power shelves, so actually the server and the storage solution we are selling are become deeper and deeper. So 800 millimeter can actually provide a better thermal between the device and this bus bar. And also it will be a much more cheaper and a flexible way to deliver more than 33 kilowatts or even further. Yeah, we do see more demands for 40 or even 50 kilowatts per shelf. So it will be more difficult to implement that by using one DC bus bar. So, okay, question? Yeah, question.
Is this the end of the session?
Yeah.
Sure. If you would go back to the slide that showed the matrix of applications. Okay, thank you. So I'm just trying to understand things, and I think what you're saying is, what you're describing now is a deep 48-volt rack with 3 bus bars in it. So you're describing where the question mark is.
Yes.
You're not proposing a change to quadrant 3 whatsoever, so the short 48-volt is still a single bus bar approach. It's only the deep one. Okay,
Yeah.
so you're just talking about the question mark space there.
Yeah, exactly.
Okay.
That's our proposal, because again, it's an open standard, so everybody can pick and choose what they needs. But
So the HPC, it seems okay. I understand.
Yes.
And I agree now that I understand scope. So thank you.
Yes. Okay. Questions? No. Cool. Okay. All right. Thank you.